So our group is heating up in the kitchen. And so have you guys ever made soup or pasta and you're stirring it with an object like a spoon and it got hot? That's probably because your object, the spoon that you're using, was not insulated, properly insulated. There are many different types of insulations that spoons come with, which is rubber, some type of plastic, or even silicone. And so in this experiment, we're trying to demonstrate what of the objects we're using has the highest thermal conductivity, meaning that gets hot the most when you hold.
So these are going to be the materials we're using for the experiment. We got an Oster hot plate, and then for the slotted spoons, materials we have plastic, stainless steel, wood, and cast iron.
This is the heat transfer principle behind our experiment. The equation at the top is the differential heat transfer equation, which is derived from the energy balance. This equation, as it's written, is a bit difficult for us to use, so we have to make several assumptions. We can assume that there is no bulk flow because there's no velocity in our system. CV is equal to CP because we're using incompressible solids. Our K is constant. Q dot is equal to 0, which is our heat generation term, because we're keeping our oil bath at a constant temperature. And phi is equal to 0 as well because there's no viscous flow. Using these assumptions, we can simplify the equation down and then divide both sides by rho Cp and create a new variable called alpha, which is the variable that we will be testing for each of our materials and comparing them to each other. We can make one more assumption for our system, which is that our heat transfer is only occurring in one dimension, and simplify it further to the equation at the bottom.
Alright, so the ambient temperature here is around 26 degrees Celsius. So the temperature of the system that we're going to be dealing with is around 150 degrees Celsius. I'm measuring from the base of the surface of the canola oil up to 6 centimeters up, and it says the temperature is around 50 degrees Celsius. And I'm going to do that for all 4 different materials we're going to be using. So right now we're measuring the temperature of the stainless steel spoon, 6 centimeters above from the base of the surface of the liquid canola oil. And it says here it is 68 degrees Celsius, which is higher than the wooden spoon. But this spoon is a cast iron. I'm also going to measure 6 centimeters from the base of the liquid surface. And it's saying that here, it's saying that it's 78 degrees Celsius. So this spoon is made of plastic. Also, I'm measuring 6 centimeters from the base of the canola oil, and it's reading it is 50 degrees Celsius. Okay, so for our results, we found out of the 4 materials we used, we found out that cast iron had the highest thermal conductivity. Second was stainless steel. Third was plastic, and fourth was wood. And this was mostly because stainless steel and cast iron have a lot of free electrons because they're mostly metal. And the plastic, it kind of was above wood just because plastic, it's made of polyethylene, so it melts at a lower temperature than wood. So here's some little facts that you guys should know when you're cooking, like let's just say soup. It's best to use a wooden spoon just because if you use plastic, it can melt. There's a potential it can melt, so it could contaminate your food. And if you use objects like this, like a cast iron that has no insulation, that could burn your hand. And as we found out, wood has a low alpha, low thermal conductivity, so it's not going to burn you as much. And you gotta watch out for wood because you can't mix soup with other objects that you're making, let's just say scrambled eggs or pasta, because wood is quite porous. And so when food and particles could get into the nook and crannies of the wood. So later on, it's going to be harder to scrub off. So that's why the best, most ideal object to use is something made from silicone, because those are they have high melting temperature. Those are they're also no slip. They don't stick.